Hi, so today, today's going to be sort of a briefer class than the previous ones, because primarily what I want to do is I want to give you guys the exam and let you guys get started on that and ask me any questions if you have any questions. I will of course be kicking around Discord throughout the weekend, so if you have any questions, um, about the test and you need any clarification, please feel free to either ask a question in general chat or to send me a private message over Discord, and I will get back to you as soon as I can. It'll be I will get back to you much quicker if you message me on Discord than if you message me through any other means because it's sort of just an automatic notification. Um, but exam structure wise, I basically am giving you pretty similar to exam to what I would have given in class. Um, so it's going to still be 12 questions. You're still going to get to choose two of them to cross off. Okay, so that means that you can um, pick two of the problems on the test. You don't have to do them as usual. Um, the exam is open note because I cannot prevent you from. There's no reasonable way in which I can prevent you from using your notes for something like this. So instead of having a note card, you guys may use your notes. However, the one thing that I will request is that you do not consult outside human resources. So um, please do not talk to math lab people, tutors, classmates, um, Tommy, any Quora or Stack Exchange or some math forum. Like, no asking for help from outside humans. The work that you write on this test should be your own. Um, so as for how I want you to do the test, um, there's a handful of different options I can give you guys. Um, the probably the easiest option for you is going to be for you to like take the test on paper, then scan to a PDF using either an app like Genius Scan or Google Lens. So there's a lot of apps out there that let you take pictures of your paper and they automatically like reorient themselves and will let you plug like 10 files into a PDF, and then you can just submit it, right? Um, if you can annotate a PDF, you can do that as well. For instance, if you have like a tablet with a pen, and that's something you want to do, you can open the PDF file on your tablet and then write on that, and then export that, print that out to a PDF, and then turn that in as your exam. Um, on my tablet, I have a Windows Surface tablet. I use Drawboard PDF. For annotating PDFs, and that works out pretty well, and it has in the past. So um, these are really kind of the two big options. The one thing that I will request is that when you turn in the exam, please turn it in as one file, so that I don't have to jump in between a bunch of different files. And if you cannot actually take the test, um, if you need to take the test on blank sheets of paper, so, for example, you don't have a printer or something like that, and there's no way for you to get the to actually write on the paper or annotate the PDF in any way. If that is the situation you're in, then please do each question on a separate sheet of paper and label them clearly. So, for example, you have that's your sheet of paper. Put a big question number 1 in the corner or something like that. Just that way I can very quickly tell which one is which. So if you do it on a separate sheet of paper, you can just submit only the questions you do. You don't have to worry about submitting different, like you don't have to submit blank pages. Although if you want to, that would be nice. Blank pages for the questions you don't do. Okay. I think that takes care of technicalities. That's sort of the administrative stuff. Does anybody have any questions about what the format of the test is or anything like that? Any technical stuff about the test? Okay, and I will post the PDF of the test here in Discord. I will also open up a D2L assignment with the exam attached, so you can get it in either place. When you are turning in the exam, you need to turn it into D2L. So, um, so must turn the exam in on D2L. If you don't turn it in on D2L, it's just such a pain in the butt for me to try and track a bunch of different sources of people turning in stuff, and that's how I forget to grade people's papers, and I'm confused because I feel like people haven't done the test. So please make my life a little bit easier here and make sure you turn your test into D2L. That way it's integrated to the grading platform and I can just give you guys the grades. I don't have to go to a bunch of outside resources for that. So okay, so content review wise, this unit that we covered here was on exponents and logarithms, right? So exponents and logarithms. The things that I'm going to expect that you're able to do is I'm going to expect that you are able to. So we started with one-to-one and inverse functions. So I'm going to expect that you're able to one, determine if a function is one-to-one. Okay, we talked about a couple of different ways of doing that. We talked about the horizontal line test. Also, the definition of one-to-one function, that every input yields a unique output. So no two inputs yield the same output, basically. So either horizontal line test, no two inputs yield the same output. Another thing you need to be able to do with one-to-one and inverse functions is determine if a function or if two functions are inverses. This is using the definition. which involves the composition of the functions. F of g of x equals g of f of x, which equals x, implies that g of x equals f inverse. In other words, to tell if two different functions are inverses of each other, you need to actually compose the two functions and show that they satisfy that definition. You cannot tell if two functions are inverses of each other just by finding the inverse of one of the other functions and saying that that's the same as the other one. Okay, you need to use the definition for full credit. And thirdly, for inverse and one-to-one functions, you'll need to be able to find the inverse of a given one-to-one function. So there was we had like a 3 or 4 step process for that, right? So this was basically swapping inputs and outputs. That was the process where we took f of x equals blank, we rewrote it as y equals blank, switched the y's and the x's, and then solved for y again. Okay. So that's most of the big 3 things I'm concerned about for one-to-one and inverse functions. Does anybody have any questions about one-to-one or inverse functions right now? You should expect to see questions on one-to-one and inverse functions that are a little bit more theoretical. Okay, so for instance, I might ask you about some sort of inverse process, or some sort of function that isn't necessarily a function of numbers to other numbers, right? So you should be comfortable with the idea of one-to-one and inverse in that way. So after one-to-one and inverse functions, the next thing that we talked about was exponential functions. So you should be able to interpret and solve exponential functions. So interpret, evaluate. And solve exponential functions. By that, I mean that, so evaluating an exponential function is when I give you a value of the independent variable. So that's stuff like if I give you a compound interest formula and I ask you how much money will you have in 12 years, right? You're just plugging in the number of years to the compound interest formula. You also need to be able to solve exponential functions. So that means solving for the independent variable when given the dependent variable. For instance, I give you a formula for compound interest and ask you how long it's going to take for you to make $10,000 in the account, right? So those are things that we did in class, and you should feel relatively comfortable with at this point. And interpreting them, one of the situations that you're like, one of the things you'll see on the test, this test has a fair amount of sort of word problems, things that are kind of sort of like real world situations in which you're actually interpreting these values. So it's just the usual, hey, if I'm giving an answer for a word problem, I should give this answer in context, right? So put it in a sentence, state what the numbers actually mean rather than just saying the numbers is an answer. All right. And as a secondary objective, you need to be able to use properties of exponents to simplify. So this is the stuff like x to the -1 is equal to 1 over x. the square root of x is equal to x to the 1/2. Those sorts of things, right? Those exponential properties that we talked about on close to the first day of this unit. Okay. Does anybody have any questions about exponents and logarithms or exponential functions? What I'm expecting out of those? There is no graphing on this test, so you don't have to worry about graphing exponential functions. All right. So the next thing that's sort of on the list of topics is expanding and condensing logarithmic expressions. So remember that expanding a logarithmic expression, you should always end up with more logarithmic terms than you started with, right? So expanding, so if we have like log base 2 of x to the 4th z squared, this expands out to 4 log base 2 of x plus 2 log base 2 of z, right? So going from the left to the right here is expanding. If you started on the right and are going back to the left, that's condensing. This uses those, like, I think there were 6 or 7 log properties. And you should also try to evaluate any logarithms you can. What I mean by that is that you should, so for example, if you have log base 2 of 8, that's 3. So don't just leave it as log base 2 of 8, you should write it as 3. However, log base 2 of 9 is, you can leave. There's not some really nice way to write log base 2 of 9 as like a nice number. It's a really long gross decimal, so don't worry about writing it as a number. You can just leave it in the logarithmic. And then from there, that brought us into solving exponential and logarithmic equations. So for exponential equations, we had three main types, I believe, for exponential equations. We had common base, for example, something like 2 to the x equals 4 to the x minus 1, right? In the case for the common base, you would rewrite the exponents to have the same base, and then you could use the equivalence property for exponents, right? Once they have the same base, if you have 2 to the power of something equals 2 to the power of something, those two powers have to be the exact same thing, right? We also had non, so I guess non-exponential terms. So for example, something like 2 to the power of x is equal to 312. Um, for things with non-exponential terms, you're going to collect all of your exponential terms on one side and then apply a logarithm to get the x out of the exponent, right? And then thirdly, we had non-common base. For example, 2 to the power of x is equal to 3 to the power of x minus 1. In that situation, you can't really write 3 as a exponent with base 2. So you'll have to apply logarithms to both sides. You can either apply a logarithm with base one of these to both sides, or you can apply a natural log. Either way, with these types of problems, there's a fair amount of arithmetic that you have to get through in order to solve, so they can be kind of messy. And then for logarithmic equations, there were two main different types. Either all log terms. If it was all log terms, you would collect log terms on both sides, okay? Condense them as much as possible so you had log of something equals log of something, and then apply the equivalence property, right? So condense on each side. Then apply your equivalence property. Log of x equals log of y implies that x is equal to y. If instead you have some non-log terms, then you'll collect all log terms on one side, then collect all non-log terms on the other. Then you're going to rewrite that as or then condense, then rewrite as an exponential function. Actually, something I should have mentioned explicitly at some point or another. Actually, up here, probably when we first talked about log expressions. Let's just write this down in big font here. Remember that the definition of the logarithm is that, so there's two of them. One, log base b of x to the x is equal to y is equivalent to the statement that b to the y is equal to x. So when I'm saying rewrite a log function as or a log equation as an exponential equation, what I'm saying is that you're going to take an expression that looks like the left-hand side here, log base b of x is equal to y, and rewrite it as b to the power of y is equal to x. Okay. Or two, log base b of x is the inverse to, so let me, here, hold on. So if f of x equals b to the x, then f inverse of x is equal to log base b of x. That is that the logarithm function and the exponential function are inverses to each other. So those are your two big definitions for logarithm. All right. And then finally, the last thing that we did in this unit, sort of the last big topic, is exponential modeling. So we did compound interest formulas. So compound interest for we had periodic compounding, which was that a of t was equal to p times 1 plus r over n to the power of nt, where and constant compounding is a of t is equal to pe to the rt, where p is the initial amount or the principal, r is the APR as a decimal, n is the number of compounding periods per year, and t is time, and e is approximately 2.71828, etc. So you'll need to be able to build compound interest formulas given that information. So I might not give you the compound interest formula. I might ask you to make the compound interest formula. I'll give you the initial amount, the APR, and the number of compounding periods, right? Like I tell you that you're investing or you get a loan and the interest is 3% APR compounding monthly, and the loan is for $10,000. And then I'm gonna ask you how much you owe after 4 years, something like that. That's an example of something I could ask about compound interest. Um, Second, we'll model exponential growth and decay. So this is frequently going to be stuff like population modeling, and in particular, we'll be using um, the function that like f of t is equal to ce to the kt. Notice that this is exactly the same as pe to the rt, right? Those are the same formulas, just slightly different letters, c and k instead of p and r. So usually I'll give you, you'll have the initial quantity and a quantity sometime later. So I might give you that there's 100 fish in a pond when they're first introduced, and then 5 years later there's 120 fish in that same pond. Make a model for the growth rate of the fish. How many fish are there going to be in 5 or 6 years, etc., like 10 years. These are the types of things I'll ask you to do with exponential growth models. Um, so be aware of um, restrictions on the, or limitations is a better way of putting it, on exponential growth models. We talked about this in last class, but all exponential models eventually are unrealistic. And just be aware of how that can happen and why that can happen. I need to jump back up for a second because I thought I forgot something really important when talking about logarithmic equations. So um, let's put this right here. So always check answers for log equations. Okay. You always must check your work or check your answers on logarithmic equations because when you're solving logarithmic equations, it's possible that you will get extraneous solutions. You may have found a solution that came about, but would have caused you to take the logarithm of 0 or a negative number, which you're not allowed to do. So you cannot take the log of 0 or log of negative number. So you should always be checking your answers for logarithmic equations. Okay. And then the last sort of thing that you really need to be aware of for modeling using exponential models is the logistic function. So logistic models. I will not ask you to create logistic models. We do not have the tools to do that. But I may ask you to interpret them or explain maybe what is different between a logistic model and an exponential model, right? So, why are they useful? And be able to evaluate, solve, and interpret a given model. And I think that is about it. It's a fair amount of information. We did have, 2.5 weeks of class since the last time we've had a test, so we've crammed a fair amount of information in there. So if you felt comfortable with the homework assignments and the handouts I've been giving out each class, you should feel pretty comfortable with this test. So does anybody have any specific questions before I hand out the test? Taylor, I think you're talking, but I think your mic is not working. Either that or my sound isn't working, and people have been trying to talk to me this whole time. I'm gonna check my sound real quick. Okay. It seems like my sound is working okay. Um, Maybe my sound isn't working. Tommy, are you speaking?